Welcome. I'm going to step through some solutions to the Chapter 6 exam practice. I will not be typing them into my calculator to save some time, but you are welcome to pause at any point and see if you can verify my answers on your graphing calculator. All right, so we're going to start with our standard normal distribution. We use z-scores to represent the standard normal distribution. So this is our special case, our special normal distribution, where its parameters are mu 0, so it has a mean of 0, and it has a standard deviation of 1. And number 2 is find the 92nd percentile z-score. So I'm going to label my axis here. So I'm going to look at z-scores. We know the center of the graph is 0. And we could include other values on the z-axis, the 1, 2, 3, and -1, -2, -3. However, we're not going to try to draw these perfectly to scale. We just want to get a sense of where things are located. So as a reminder, the 50th percentile would be the center of the distribution. So 50% of z-scores are to the left of it. We want the 92nd percentile, so 92 is bigger than 50. So I know somewhere over here is the 92nd percentile z-score. And the definition of the 92nd percentile is that 92% of data is to the left of it. So that graph is the definition of the 92nd percentile. So if we want to find that z-score that represents the 92nd percentile, we just inverse norm that %92 written in decimal. And usually with inverse norm, you need to put in the mu and the sigma. But if you leave those out, it's the default on the calculator, and the calculator will assume it. So usually just to save some typing, we do leave that off. And then, like I said, I'm going to write down answers here, and you're welcome to check them, but we're rounding our z-scores to 2 places. So that should be 1.41. And just a quick check that it makes some kind of sense. 0's in the middle, so I did expect my answer to be a positive z-score. All right, and then just for completion here, just to remind you that with percentiles, if 92% of z-scores are below 1.41, that would mean the other 8%, area to the right of it would be the other 8%. And that 8% is because 100% minus 92% leaves me the remaining 8%. All right, let's try another percentile over here. So now it says find the 10th percentile z-score. I'm just going to label my axis z, and there's 0, the 50th percentile. Now, if it's the 10th percentile, 10 is smaller than 50, so I know that z-score is to the left of 0 on the number line. And again, percentile tells you the percent of data less than that value. So the area to the left is 10%. So if we want to find that z-score, the 10th percentile, we can inverse norm that area to the left of it. And you can check that out, make sure you get negative 1.28. A negative answer makes sense on the number line because negative 1.28 would be less to the left of 0. All right, and then again, just kind of for completion here, if I know 10% of z-scores are less than negative 1.28, then the area to the right of it, so take 100% of z-scores when it's 10%, that would leave you 90% of z-scores that would be higher. So when I look at these pictures, just guaranteeing here the math makes sense with areas 92 plus 8 would be the whole graph, 100%, so shaded and unshaded. And here shaded 10% plus unshaded 90%, add those up, we get 100%. So the graphs look good. Okay, so for number 3, so find the z-score that corresponds to the shaded area. So the thing to point out here is that on 3A, we're looking for that z-score, and they shaded the area to the left of it. Let me compare that to this picture. We're looking for this z-score, but they didn't shade the area left of it. They shaded the area to the right of it. And we know to find z-scores, we always inverse norm the area left of the z-score we're trying to find. So for A, we can go straight to inverse norm because we have the area to the left of it. Let's check that out. That will be negative 1.86. And that makes sense here. 1.86 is left at 0. But on B, they gave you the area right of the z-score, so we have to find the area left of it to use inverse norm. So area left is 1 minus area right. That will be 0.1766. Now we can inverse norm. So we can inverse norm that area to the left of the z-score we're trying to find. And that will be negative 0.93 on the number line. All right, so that answer is also negative, and it's right there. All right, just a quick note. Reading the negative per second, 0.93 has nothing to do with 93%. So these z-scores are not percentages. These z-scores are numbers on the number line. They're not areas. So this area could be written as a percent. That's 82.34% of the graph. But z-scores are not areas. They're just numbers. All right, so even without a picture, we should be able to do these. So find the z-score so that the area under the standard normal curve to its right, so the area to its right is 0.9601. And we're immediately going to say, well, I need the area to the left. So 1 minus the area to the left. Give your area to your right for that z-score we're trying to find. And then you can inverse norm that area to the left. All right, that'll be negative 1.75. And then for B, find the z-score so that the area to its left is 0.9601. So we can go straight to inverse norm because you always inverse norm the area to the left of the thing you're looking for. Okay, and that one will be positive, 1.75. All right, so just remember, inverse norm area left. Inverse norm area left. If they give you the area right, find the area left and inverse norm. If they give you the area left, go straight to inverse norm. All right, just a couple more of these. So 5A here. Find the z-score that cuts off the bottom 2% of z-scores from the rest. So when they say bottom, we know that's the area to the left of the z-score we're trying to find. And if it's the bottom, the area left, you can find it by going straight to inverse norm. Check that one out. negative 2.05. So again, I'm not bringing up the calculator just to save me some time, but certainly pause and you can enter those and check that you're good. And then for 5B, find the z-score that separates the top 15% from the rest. So when they say top, that indicates the area to the right of the z-score needs to be 15%. And you're going to say, I need the area left of it. So 1 minus the area left gives you the area, I'm sorry, I need the area left. So 1 minus the area to the right gives you the area to your left. And now you're allowed to inverse north that area to the left of that z-score to learn that that z-score is 1.04. So I would love to draw pictures for you for everyone, but it does get kind of long that way. But the visuals often do help us see that our answers are correct and it's all kind of coming together and making sense. All right, and then I'm going to end here on this page with some probability questions regarding z-scores, just to remind you that the order you enter the values makes a big difference and we need to get them correct. So if we're looking for probability or area, it's normal CDF. And if it's a greater than question, that indicates we'll be shading numbers to the right of negative 1.05. So the greater than case, we would start at that value at your lower bound, and your upper bound is our infinity substitution there, our E99 for infinity. And usually you would have to enter the mean and the standard deviation. So again, for z-scores, but we can skip writing those two. That is the calculator default. Or you can type them in if you would like and double check that answer. It should be 0.8531. And I'll always let you know if I want decimal or percent. Here I'm just practicing both ways. So 85.31% of z-scores would be greater than negative 1.05. All right, so greater than case, your upper bound is infinity. The less than case for finding probability, so normal CDF. For the less than case, your lower bound is negative infinity. Your upper bound is that value they give you. And again, you can skip the 0, 1 for z-scores and enter that and check. It should be 0, 1, 6, 2. And again, just for practice here, 1.62% of z-scores will be smaller than that value. All right, so that page covers z-scores, and then the remaining 2 pages will cover our application.